Welcome to week two's recorded lecture. Today we're going to talk about designs, like study designs, different kinds of research designs. We'll talk about participants a little bit. We'll talk about independent variables versus dependent variables, the IV and the DV. And we'll talk about hypotheses. All right. So there are three major groups of design types. The major groups, and this is something that you'll have to remember throughout the course, and you'll see this over and over again. There are frequency designs, association designs, and causal designs. So you can't, you've all heard over and over at this point probably, correlation is not causation. So you can't say something happens, something's causal, if the only data you have is correlational. So there are special kind of requirements for a causal experiment or a causal design. So we've got those three types. Tell me about the thing, that's frequency. How much does it happen? What does it look like? Tell me about it. Association would be, tell me about the thing in relation to another thing. And so in a frequency, there's really only one thing you're looking at. In an association study, you're looking at two variables or more than two variables. And so how do they relate to each other? How do they co-vary? And then a causal experiment will look at what makes something happen. And you have to control the other things so you know that the reason that it happened was because of the variable you changed and not because of some other variable. So those are the three basic types of design: frequency, association, and causal designs. And as we talk about each of these, your job is to think about your idea. And so at this point, you have an idea and you have a measure. You have several ideas and several measures, but start thinking about which one you might be most interested in looking at. And then look at these types of designs and think about, does your question fit more into a frequency or into an association design or into a causal design? And you'll definitely have plenty of opportunities to interact with me about this, because the first time you do it, it's not obvious. So it's fine to have lots of questions. One of these examples might be something you're looking for, though. So let's kind of go through them and think about your idea and see if it fits into one of these three types of designs more easily. So one is of the frequency. One could be a case study. That would be one person, a case, one case. Or you could have an observation on a group, one observation like the rate of depression, right? Or what's the rate of ADHD at SVU? Or how many people get married when they're at SVU? Or how does the SVU average anxiety, the students' average anxiety, how does that compare to other people's, to like say BYU's? And so that would be a frequency example. Association examples, here you're looking at the relationship. How does this relate to that? How does it vary? How does it co-vary, really? What's the correlation between the two? The correlation is the covariance. How does one change and does that affect the other? And so you're looking at least two different variables. And so you might say, I'm looking at anxiety and I'm looking at ADHD. And so do people who have ADHD tend to have more anxiety at SVU? So that would be a correlational example, an example of a study of association. Or you could say, is my attention more functional, we could say, to have better attention, to have better focus when I am sitting next to my best friend or when I'm not sitting next to my best friend? And so the presence or absence of one variable versus another, okay? You can look at association. And then we can look at causality. So does X make a difference for Y, right? If I give you broccoli, Does it make you feel like lifting weights? Okay. And so that would be a causal study. And so I would have to control everything else. So let's say some of you have a best friend that says, hey, come lift weights with me. And others of you have a best friend who says, hey, come eat Captain Crunch with me. And so we want to take away the influence of any of those best friends and only look at the influence of broccoli on urges to lift weights, right? So a causal example is an experiment where you can randomize people to a treatment or not. So let's say the treatment is half of them get broccoli and half of them don't get broccoli. So that's the treatment, and you have to randomize who is in the treatment group, who's in the group that gets broccoli, and who is in the group that doesn't get broccoli. It has to be randomly assigned. If you don't randomly assign it, then it might be that there's some other thing, some other systematic difference between those groups that will do a better job of explaining the impact on weightlifting of broccoli than actually broccoli does. And so let's say people would prefer to lift weights earlier in the week. And so you ask people to be in a group that lifts weights Monday, Tuesday, Wednesday, and in another group for Thursday, Friday, Saturday. And let's say you find a difference in those two groups and you think it's about broccoli, but really it's about time of week, day of week, right? So you have to keep everything else the same. When you keep everything else the same, we call that controlled. So you're controlling all the other variables, and the only variable that gets to change is whether or not they get broccoli. Got it? So that's an experiment. Sometimes you can't randomize. Sometimes you're not able to randomize. So let's say you're looking at the effect of smoking. You can't randomize people into a group and tell them to start smoking. Like, it's not ethical, right? So we can't do randomized treatment. You can do a quasi-experiment. And so you can do it as good as you can. That's terrible grammar. Terrible grammar. Okay, do it as well as you can, but you can't randomize. So you can control everything else as much as you possibly can. And sometimes you can come up with some great results that are very helpful, but it's a quasi-experiment. So those are examples. So now think about your idea. What design, which of those three global kind of designs, and maybe what more specifically would work well for your idea and your measure? So think about that. Jot some ideas down. What participants would work well? Do you want to look at people who are in nursing homes? Do you want to look at people who have children who are 3 years old? Do you want to look at college students? Do you want to look at music majors? Do you want to look at people who are Republican? Do you want to look at people who have enjoyed the smell of daffodils in their life? You know, there are all kinds of ways you can group participants so that you're looking for a particular group that you're going to include in your study. You could say, my study is on everyone who's an adult. So if you're 18 to 65, that's generally the age limits for being in a study. 18 to 65, you can be in this study, and you're my population. The average general is 18 to 65 years old. There's a danger in terms of what population you choose, because the population you choose may have some reason for responding in a certain way to your treatment or to the survey. So let's say you took a survey of how frequently you exercise, and you find out that people who are, 64 and 65 exercise less than people who are 24 and 25. Well, that seems like that would be obvious, right? Because that age range probably exercises less. They probably don't sleep as well, okay? So think about that. In traditional research, or I guess traditional isn't really the word. In the past, what we have done a lot of is study participants who are convenient to get. And it's super convenient to get college students as participants in experiments. You go to college and they say you are required to put in a certain number of hours each semester in helping us do research by signing up as participants. And so you've got all kinds of people who are volunteering right and left for experiments. And so what you know is we know a lot about college students, but can we really apply that to people who are in their 40s or et cetera? And so that is an instant, that's a typical example of what we would call external validity. Is it valid outside the study? External to the study, validity. In other words, does your thing hold true for people who weren't in your experiment? So if you do an experiment on college students, is it externally valid? Can we apply the results to people who are in their 40s? There's a danger of using mostly men. So a lot of times medication studies, drug studies are done on men, a little bit more than women in the past. And so what has happened is women have many more side effects than men for the same drugs because the studies have been done in large part on men and less inclusive of women. That is changing now because people are starting to see that this is a big problem. And guess what? Women's bodies are not like men's bodies. And so if you decide this is the dose that really works for people, and the people you studied were men, then the people that you didn't study were women, the dose may not work very well for women. And so then you have women getting more side effects. And so there's a danger in terms of choosing a lot of the same type of participant population because you don't get externally valid results as much as you think you are getting externally valid results. Same with the danger of using mostly one racial group. There may be some genetic differences in terms of how the body handles certain things that happen in terms of groups of people that were all raised in the same area. And what I mean by raised, I guess I mean have had many, many, many generations that have developed sort of some genetic differences. And sometimes those are racial differences, sometimes they're not. But there's a danger then when you use only one type of person in your study and then you expect to apply those findings outside that type of person. And that's that danger of external validity. So when you think about your idea, think about what participants would be great for your study. Now, here's the cool thing about this is your imagination. You're not going to actually do this study. And so don't think about, well, I don't know if I could get this many people. I don't know if this is realistic. Because here what you're doing is you're designing a study. You're not worrying about actually implementing the study. And so if you want a particular population, just make that decision. This is the population I want for this, and we'll sample that population, figure out how to do that later. And you can use it because we're making this up, right? You're not actually going to have to go do it. And so when you think about your idea, the sky's the limit, really. What design do you want? What kind of participants do you want? And you just write your study up as if you can get those easily. All right, so now let's talk about what is an independent variable and what is a dependent variable. Some of you may have known this since 8th grade. Some of you, this might be brand new to you. It is not that hard. It's about experiments. And so if you have an experiment, then you have an independent variable and a dependent variable. If you don't have an experiment, you don't have an independent variable because you're not manipulating the independent variable. So if your study is a frequency study, you don't have an IV or a DV. If your study is an association study, again, you don't have an IV and you don't have a DV. They don't apply. The only time independent and dependent variables apply is when you're conducting a study of causality. You have an experiment or a quasi-experiment. You're manipulating one of the variables. So what manipulating means is you're giving one group one thing and one group the other thing. Either you're giving them broccoli or no broccoli, or you're giving them, one group gets broccoli, the other group gets cranberry juice, whatever it is. There could be all kinds of variables that you manipulate, meaning that you are managing who gets what. You're deciding who gets what variable. That's the manipulated variable. It's the variable you're in charge of. The dependent variable is the variable that you're measuring to figure out what happened. It's the outcome. And so again, if we're going to use our broccoli and weightlifting urges study, so to remind you, or to set it up better, let's say we're doing a study of college students, and we're going to see if eating broccoli makes them want to lift weights more. And so we have to have a measure. The measure would be looking at how much do you want to lift weights right now? Like, I really want the urges to lift weights. We could call it urges to lift weights measure. So if we're operationalizing the construct, the construct is how much you want to lift weights, the operational definition would be the measure, urges to lift. Okay, so we'll call it urges to lift. That's the dependent variable, because what we're looking at is what's the effect of broccoli on urges to lift. So we're going to look at urges to lift to see if there's an effect of broccoli. So urges to lift will depend on whether or not you ate broccoli or not. That's our hypothesis. So the independent variable would be, did you get broccoli or did you not get broccoli? And the dependent variable would be, what are your urges to lift? The dependent variable, urges to lift, is how that construct, how much do I want to lift weights, is operationalized using like a questionnaire or a test that's called urges to lift. Make sense? Okay, so short one today, right? Because you're in the middle of other readings, you're in the middle of projects for me. I just want to make sure that these these concepts made sense to you in a way where you're not we're not lots of noise and interference, and so you can definitely hear and make sense of this on your own time when you want to. So to sum up, we talked about independent variable, dependent variable. We talked about types of design, frequency, association, and causality, okay? And what your job is now is to start thinking about what design would work for you and what population, who are the participants that you would like in your study. And then you're going to do that work in your development interaction with me this week. And so read the chapter 2, if you haven't already done that. Take the quiz. Remember, this is closed book because I want you to practice trying to remember these things. And because studies show that if it's closed book, you're more likely, the recall part of the quiz really helps with learning a lot. And just using an open book, it doesn't help very much. So I'm interested in helping you, and so we're going to do it closed book. So take the quiz, do the development interaction. I'll comment on it, and then you have to respond to my comments. Then come to class next week, and we'll apply what we learned this week in class next week, and it will be awesome. Okay, great. Enjoy your day.